This is now our LED cube, 3x3x3 from using 5mm LED. And we're going to drive this LED cube using Arduino Uno Microcontroller. And also by using the code of this microcontroller Arduino Uno. Let us upload the code of this Arduino. This is now our module connected. It's the Arduino Uno microcontroller with transistor, resistors, and then the LED 3x3 module. 3x3 that cubes LED cubes. Since we already finished, we are done with uploading, we can now test the project using 9 volts to the battery connector. We have in figure 1 the 3x3x3 LED cube schematic diagram. So we have this Arduino Uno, 9 volts battery, the supply, and then the ground. The ground of Arduino is connected together with all the ground of the transistors. So you can see here the transistor here, and then some resistors, and then these are the LED blue. This LED connection is the same as this one, the actual. So you can see here in pin number 2 of the Arduino pin, we have the transistor. We have this 1K resistor to the base of the transistor, then emitter, ground to the collector. And controlling the or driving this cathode side of the LED array, LED. So this line or the row is equivalent to the, when we are assembling an LED, this one, this all square, this square is equivalent to this. That's why it is top. The second square, the middle, and then the third, the bottom. So you can see all the cathode are connected to each other. You can see here all the cathode are connected together, so forming this square type or cube. So you can see, and then we are using transistor. For the second, for the middle, we have another transistor. And then for the third, the bottom, another transistor from the pin number 4. Why are we using transistor here? Because we are, because of the LED. Because we're controlling the anode of the LEDs. So if we're planning to turn on this LED, we're just going to set the anode to low, to high, and then the anode high, and then the cathode high. So how can we do that? By injecting a current here. at the base of transistor, forward biasing this transistor, and then it will close, it will turn on this transistor. So we need pin number 2 to be active and pin 5 to be high. So we need this R4 or pin number 5 to be high and pin number 2 to be high. So high, or make it high, activate using the code. So that's why also this one, the square of this one is connected to the collector of Q1, like this one, connected to the collector of Q1. This one connected to the collector of Q2, and collector of Q3, the bottom, pin number 4, R3, 1K, and all other resistors, they are all 330 ohms. Resistor for pin number 5 connected to here, 6, 7, 8, 9, 10, 11, 12, 13. Just like in the actual, you have 5, 6, 7, 8, 9, 10, 11, 12, 13. That is the actual. Here it is 5, 6, 7, 8, 9, 10, 11, 12, 13. All anode are connected. Just like here. All anode of the LED are connected. All anode. So it becomes number 5. All anode. Number 5. All anode. So if we're planning to set this high or to turn on these 3 LEDs, we're going to set this transistor high, and this one also high, and also this one high, so that if this is high, 2, 3, 4 high, and also pin number 5 high. So when it is high, it able to control this anode, or it will turn on all these LEDs because they are going to flow it to the ground. All is grounded. Okay, grounding. When it is high, injecting current here, power biasing this transistor, it will turn on this LED. This one, and this one. So we can manipulate any LEDs. If we're planning to turn on this, or for example, this part of an LED, we're just going to set the anode high and the cathode. Anode high and the cathode high. Set this high, activate that using the code. So all in all, why are we using 2N2228 transistor? Because we are driving 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 LEDs with a current of, for example, I think it's around 10 milliamps to 20 milliamp each, times 9, 180 milliamps. So this transistor is capable of handling the current, all the current, if we're going to turn on all these LEDs at once. So it can carry all these LEDs, for example, these LEDs, to the collector of this Q3, and then turning on this transistor, because we are setting this pin number 4 high. So we have now the output, forward biasing, and then all these transistors are active. All these LEDs are active. So it's a matter of multiplexing signal. I mean multiplexing these LEDs. You can see that in the code, especially with the code used in Arduino Uno. And these are the construction of our project. If you're planning to turn on this LED, you need to set this pin number 13 high, and also since we're planning to turn on this LED, set this line high by turning on this transistor. So 2 and 13. To turn on this LED, we need to set 13 high and also pin number 2 high. So if it is high, it will inject a current here and forward biasing or switching on this transistor, and it will make this anode to turn on or to activate. So any of these can be done using the code and with the use of this remember that we need reminder that we need this resistor as a current limiting to the current limiter to the LED. Without the resistor, this one, our LED will be damaged, will become will bust or will damage. It will damage the LED if we do not have this resistor. Okay.
Station Sunset. This is their current situation. That's going to be at 3:34 p.m. Pacific.